Welcome to all the students of 9th standard. So on the request of students of 9th standard, I am doing the chapter Quadrilaterals, exercise 8.2, question number 2. Let me read the question first. ABCD is a rhombus and PQRS are the midpoints of the sides AB, BC, CD, and DA respectively. The question asked is, show that the quadrilateral formed PQRS is a rectangle. That means the figure formed by joining the midpoints of these sides of the rhombus together should make a rectangle. So very clearly it's understood that it is again the midpoint theorem. So dear students, let's start with the answer. So when you join the opposite vertices, that is A and C, you get diagonal AC and BD. Let me take first the triangle ABC, triangle A, B, and C. In this triangle, you know that P and Q are the midpoints. Where the midpoint theorem says the line joining the midpoints of the two sides is always parallel to the third side and also half of it. So part 1 is given. Now let's take the triangle ACD. That means the other half, downwards part of the part which is below ACD. So in this again, you know that S and R are the midpoints. The line joining the midpoints SR is always parallel to the third side AC and also half of it. So you have SR parallel to AC and SR is half of AC. So you mark it as 0.2. Now, you have PQ is parallel to AC, PQ parallel to AC, and SR is also parallel to AC. So definitely PQ should be parallel to SR. And both of them are equal to half of AC. So therefore PQ will be equal to SR. So PQ, one set of sides are parallel and equal. We have done in question 1 also. So PQRS is proved to be a parallelogram. One half of the question is solved now. Let's go to the next half. So now here, let's draw the diagonal BD. Let's draw the diagonal BD. BD divides this rhombus into two parts, ABD and BDC. Always draw the figure, students. And then children, you draw the figure and you keep marking them, noting down the points. That will help you solve the problem easily. Now, I am looking at triangle ABD. And you know that P and S are midpoints of AB and AD. So PS is parallel to BD and PS is also half of BD. Now this is the left part. Now let me go to the right part. Right part is BDC is the triangle. In that Q and R are the midpoints. The line joining QR is parallel to BD and is also half of it. So you come back to the same, with the diagonal AC. What you have seen is PQ and SR. PQRS is a parallelogram. And here, again, you're getting that LMNQ is also a parallelogram. LMNQ is also a parallelogram. But in LMNQ, we know that ABCD is a rhombus, correct? When ABCD, what are the properties of a rhombus? The diagonals, they bisect each other at right angles. Specifically in a rhombus, the diagonals bisect each other at right angles. So what does this prove? What does this prove? So this is 90 degrees. This LM and Q is a parallelogram, and in a parallelogram, opposite sides are equal and opposite angles are equal. So if this is 90 degrees, this is also a 90 degrees. So if one angle in a parallelogram is a right angle, LM and Q becomes a rectangle. So in PQRS, which is a parallelogram, one angle is a right angle. So PQRS becomes a rectangle. Hope you have understood, students. Let's quickly go to question 3. Dear students, if you're going to have your annual exams and you will be thoroughly revising the syllabus for term 2. So if you have any doubts, put up in the chat box so that I can go through it and do the problems which you need for the annual exam preparation or term 2 exam preparation. So let me go to question number 3. All of them look similar. ABCD is a rectangle. PQRS are the midpoints of the sides AB, BC, CD, and DA respectively. Show that PQRS is a rhombus. What is a rhombus? Rhombus has all the sides equal, all the sides are equal, opposite sides are parallel, and opposite angles are also equal. So let me go to the same procedure as question number 2. Join the opposite vertices. Draw the diagonals. Let me draw diagonal A, C, and VD. Drawing diagonal AC and VD. Now, P is a midpoint. Let me take the first triangle as triangle ABC. P and Q are the midpoints. So PQ is parallel to AC and PQ is half of AC. So this you can take it as point 1. Let me take the other part. This was on the above of AC. Now take the triangle which is below AC, below the diagonal AC. This is a triangle ACD. Now, S is a midpoint and R is a midpoint. Join the midpoints. SR, the midpoint, line joining the midpoints is parallel to AC and also half of AC. So you get from 1 and 2, we get that PQ is parallel to SR and PQ is equal to SR. So PQRS is a parallelogram. Now we need to prove that it is a rhombus. So when will a parallelogram become a rhombus? When will a parallelogram become a rhombus? When the adjacent sides are equal in a parallelogram, automatically that parallelogram becomes a rhombus. So let us see here. Now let me take, we have already taken triangle ABC, triangle ACD. Now let me take triangle BCD. Let me take triangle BCD. In triangle BCD, This is triangle BCD. In triangle BCD, Q and R are the midpoints. The line joining the midpoints is half of the third side, that is BD, and also half of it. So we know that opposite sides in a rectangle are equal. And also the special property of a rectangle is that its diagonals are also equal. So when the diagonals are equal, so what do you get now? PQ was equal to half of AC. Now QR is half of BD, right? But AC and BD are equal. So naturally PQ and QR are also equal. So once the one pair of adjacent sides are equal, this parallelogram PQRS becomes a rhombus. So hence it is proved, where the adjacent sides are equal, in such a case, it becomes a rhombus. Thank you, children. We will do the remaining problems in the next video. So see you soon. Thank you very much.